Yes, sir, it is.
Okay, thank you. Yeah, thank you. So thanks once again for inviting me to this podium, to the organizers and Kutizar and Shajin sir. So with this introduction, we will start my talk. Maybe I will cover the energy scenario, importance of energy conversion and storage, energy like green hydrogen technology, solid oxide fuel cells, energy storage devices like supercapacitors, batteries, and zinc ion batteries, this kind of things, and triboelectric nanogenerators. So before going to my topic, I will just introduce my pathway, like my career path. So I started my uh, schooling and all from my native place. I belongs to Malappuram district. It's called Kisheri, which is near to Kondoti, near to the airport. And then my UGD is from Mambad MES College, affiliated to Calicut University. And then I moved to Calicut Muslim University for my master's. Calicut Muslim University, you may all know that the library is very famous there. The university library is the second largest library in Asia, and there is many like the ancient books and many collection of books are there. And at a time, 5,000 students can sit and work. There are 7 floors and maybe 7,000 seats. So so many importance are there for that library. Many students, they come and join some course in maybe some art subject or something, but they do not attend the class. Instead, what they do, they use the library like civil service and other competitive examination they prepare, and there are many examples of successful. And then I moved to like National Institute of Technology, Tiruchirappalli for the PhD program. You know, the NIT Trichy is the number one NIT in all other NITs in India. And there are many fests in there are 3 fests like in a year. September. September means it is cultural fest in September. Usually it's conducted in September. That's why the name is September. It is very famous there. And there is Pragyan, that is technical fest, and NIT fest also is there. There are many indoor grounds and floodlight grounds and all. So I enjoyed that. And then after my PhD, I moved to South Korea. So South Korea, you may all know, like younger generations, they are very they are fans of BTS. BTS is very famous there. But unfortunately, I didn't know about BTS. So when I joined, and after 2 months, I gave a talk to one school in Malappuram. So at that time, the students, after my talk, I asked, if any doubt you can ask like that. Then people just started about asking BTS. Then I was searching the slide where I discussed the BTS. Then only I came to know that BTS is a band, it's a very famous band. So you may also know. And then South Korea is again, it's a beautiful country. Like it's very small. It's maybe a little bigger than Kerala and it's smaller than Tamil Nadu state. But their economy is very good. Like you know the Samsung, LG, Kia Motors, Hyundai. This also belongs to South Korea. So how they became such a nice, such a like developed countries? Like you know there was a war, Japan-Korea war. So in that, Japan totally destroyed Korea, and they were like, but Japanese are like they are very good people. It's not like British people. They didn't give us any compensation, but Japan, they gave the compensation to the country South Korea. So the president, what he did is he didn't distribute that money to the people, common people. Instead, he invested all this money some like industries. So that is the examples of this Samsung, Kia, LG, and all. This is how it came, and now they are like a developed country. So their economy is very good. So later, the people, as a token of love, what they did is they arrested him and put in jail. So that's what happened in every country. But anyway, South Korea is a very beautiful country. You know, all the season you can enjoy there. In Kerala, we will not get all season. Like we have only summer, rainy, and sometimes winter is very like it's not that much. But you can see all the seasons in Korea, and in all the season, what they do, they have some speciality there, their plantation, and also they always explore all these things. There is cherry blossom. Cherry blossom is very famous in South Korea. That means the cherry tree. You may study under the cherry tree. There was one chapter right in I think 10th standard English book. Yeah. So the cherry tree is very famous there. That cherry is not like what we eat. It's not edible, but it's a small kind of a small black seed. But that blossom time, the Korea, entire Korea become very beautiful. It is there in other countries also, but Korea, what they do, they nurture this, they planted all these cherry trees in throughout their country, and the country becomes white and different colors. Different colors are also there for this cherry tree. So it is the blossom time is maybe maximum 1 week they get, but throughout the year they invest money for this one. And within this 1 week, uh, they like many tourist people come from different countries and across Korea also. So they get whatever they invested, maybe more than that. So I'm saying that so whatever possibilities that they explore everything, and you can see their buildings and all. So this like our ancient buildings like the homes. So they maintain that one. And everywhere in my university, you can see this is my university campus. In university campus itself, you have all these like you have the gardens, cherry tree roads are there, and there is trekking areas, and there are many dams, many ponds. So they like that they maintain the beauty, and they invest for that also. And this was my stay there, and this was my group. The people are from different countries, from Taiwan, Egypt, Ethiopia, and Nepal, Indonesia, and it's me. And this is in my campus. We cannot imagine in India this kind of campus. And this was my professor, my postdoc professor Jajan Shim, and these were the research professors, and these are the students there. And every celebrations we celebrate together in our lab, like whatever, like Eid, maybe Christmas, all whatever celebration we celebrate in our lab there was a separate kitchen kind of things there. And so every day, morning and evening for the tea session, we all will gather together and we speak, we chat each other. So that life was very good. Professor also joined with us. And birthday also for every people, there was a calendar. We mark the birthday dates for all the lab members and we celebrate. And often we do, yeah, this is my lab. So this is the CVD system, chemical vapor deposition and tubular furnace. And this is the electrochemical workstation from Auto Lab, multi-channel workstation. So I was working on these areas. And often we go for trekking, we go for kayaking, we go for some outing. So every year, 2 times we go. So this kind of activities were there. And then after that, I moved to VIT AP. It is in it's VIT, Vellore Institute of Technology in Amaravati campus. That means Andhra Pradesh. That's why the name is VIT AP. So this campus also very beautiful. You can see the master plan of that campus here, and this is the current building. So this is also a growing institute. By the time I got this Inspire faculty fellowship, so then I thought, okay, my parents, they are getting older, so they want my presence. So that's why I thought, okay, at least 5 years I can stay in my home. So I came back to India, Kerala, and now I'm working as Inspire faculty in NIT Calicut. Okay. So NIT Calicut, it's also again a beautiful campus, you all know, so I don't want to introduce much more. Okay, coming to the topic, we start from the material science because basically I'm working on energy materials, so this comes from the material science. So we know that without materials, there is no engineering. So everything we need a materials, right? So depending upon the properties, like we know there are many properties, different types of properties for materials. So we can classify like mechanical properties, electrical properties like conductivity, resistivity, and all, and dielectric properties are like the capacitance and all. Then magnetic properties, optical properties, corrosion properties, and biological properties. So we can see many properties for the material. So this is how like depending upon the property of the materials, we classify also the physics like or the material science into the different category. So I work on energy material. So why energy? Energy, we know that the ultimate factor which controls worlds the movement and everything is that depends on energy. Without energy, we cannot stay, right? So day by day, the consumption and demand is increasing exponentially. And as Shajil sir mentioned in the introduction, because of the war also now people are facing this issue, now we have the shortage of commercial gases, and petroleum products are the price is getting high. So this all because without energy, we energy is a inevitable component in our life. And also we know the now we focus, we are getting the energy from the non-renewable sources, especially from the fossil fuels. So we know the drawbacks of fossil fuels. So the first one is its availability. We have only limited source. Maybe we can move using the fossil fuels another 80 or maximum 100 years. We do not have any much more sources to run our world apart. So now people are started to thinking about the alternate energy. That means what we can do, what alternate source we can find instead of these fossil fuels. And also, other than these limitations and availability, we have some other problems the environmental issues like the global warming and all. Because the fossil fuels, we know, these all are non-renewable energy sources. At the same time, they are they emit gases, pollutions. They create pollutions. The vehicles what we are using, maximum majority vehicles comes from the petroleum fuels, right? So we have the emission issue, we have the pollution issue. In the winter season in Delhi, they suffer like anything, right? So we know all these issues. That's why people started thinking alternative energy and for the green environment. So coming to the alternate energy, first we should know what are the sources, energy sources available. So coming to the sources, we can classify as renewable energy source and non-renewable energy sources. So coming to the non-renewable energy source, we know it's like oil, natural gas, coal and all. And there is a nuclear, this is a point of debate, whether it is renewable and non-renewable. Now coming to the renewable energy source, we have biomass, solar, we have geothermal, we have wind, we have water like hydropower and all. So these are the energy sources. So instead of using this coal, we have to switch into the renewable energy source. Then coming to the renewable energy source, we should move with biomass energy. We should move with solar energy. We should move with geothermal energy and wind energy and hydropower energy. So yeah. Now in 2016, the statistics says that the world using 84% we are depending on non-renewable energy source, and only 11% we are using from renewable energy source. That means the majority, 90% comes from approximately 90% comes from non-renewable energy source. So that creates a lot of issues. So this is the current scenario, the increased demand of energy and shortage of fossil fuels, and at the same time the environmental issues and pollution issues using these fossil fuels, and global warming, greenhouse effect, all these. So according to the World Energy Council in 2017, the growth in energy consumption has been higher than anticipated in the high growth scenario. So to enable the development of our sustainable economy and society, we should move to the clean and renewable energy source that can only substitute the fossil fuels. So this is the only source we have. This is the only way we have to overcome these challenges. So there is another energy storage that we will discuss in coming slides. So before going to that, it is the latest statistics from 99 odds. So this is like the installed energy generation in India. We have still you can see that 51% of the power plant we installed comes from the diesel plant or coal, and 10% from wind power, 10% from solar power, 2.5 only from biomass, and it is almost 1% only from small hydropower. So there are small hydropower and hydropower from dam and all, key plants. So we have a lot of issues still we are like we have to move forward. And nuclear is again it's give very good impact, and it can meet our demand, but people are like afraid of using, and there are many economical issues using that. But this is like a one-time investment, so that's why the country also now moving to improve the nuclear plants. The Kudankulam plant now. It's also like the growth we can see, and then gases 6%, then hydro plant 12%. So coming to the Kerala, we our majority of our energy harvesting is from the hydropower, but still it is not enough. We are like buying from other states and all, and 1.7 it comes from lignite. So India has ranked third in renewable energy installation in 2021 as per the Renewable 2022 Global Status Report published by REN21, that is Renewable Energy Policy Network for 21st century. So about 42% of India's total installed power capacity comes from renewable energy source. That doesn't mean that 42% we are using from renewable energy. This means the power plants we have installed, out of that 42% comes from renewable energy source. And India ranked fourth in total solar installed power. It's almost 60 gigawatt for 2021, overtaking Germany. And in December 2022, India had 41.8 gigawatt of wind energy and 61.9 gigawatt of solar energy in place, according to the Ministry of New and Renewable Energy Ministry. And project worth $2,000 billions are underway in India for the renewable energy sector, as per the International Energy Agency reports. So that's why people like me are getting funding from country to develop this kind of technology. So yeah, now coming to the distribution of this renewable sector, there are different types of renewable energies in India. This also I got the information from the 19 notes. So you can see this is 10% comes from biomass, and small hydro is 7%, and majority is 47% is from wind power, and remaining 36 is from solar power. So this is the statistics of the distribution of renewable energy sector in India. Now coming to the solar energy, we know that solar energy, there are two types of solar energy. One is like using the photovoltaics. It can absorb the light energy and it can convert to the electricity. And another one is like the thermal energy from the radiation from the sun that we are using, and we are putting to some channels, and we are using that for the electricity generations and other kind of activities. So these two types are from the solar energy. And coming to the solar parks, energy parks in India, there are like in Badla, it is in Rajasthan, more than 2,000 megawatt, and Rewa, it is 750 megawatt, and Shakti Stella around 2,000, and Kurnool, Andhra Pradesh, that is 750 megawatts. So this is the distribution. You can see the solar energy parks in India. And you know the Cochin Airport. Yeah, the Cochin Airport is completely run by the solar power. So you can see there are many large area of solar plants and solar panels. Now coming to the wind energy, you know, this is just the conversion of wind to the mechanical energy and then to the electricity, right? So what they do is the turbine rotates using this wind, and the issue is like we need a lot of investment for that. It is not like but it is a long-term investment. So that's why we can get whatever we invested. But the issue is like there are many issues for wind generation, like environmental issues are there, like birds and all while flying, they get killed by the turbine blades of this turbine. And the residential area is very difficult to put it in the residential area because it's make noises and sounds. These issues are there, but still in India we have many wind energy farms You can see the distributions in the figure, like Jaisalmer and yeah, Brahman well, and yeah, many places are there. You can see here. And coming to the hydrogen, it's other types of energy. It comes from the water. So this is new technology. Like we are splitting the water, right? Splitting the water. We know the constituents of water is like a hydrogen, 2 hydrogen and 1 oxygen. But it's 2, right? So if we can, like, if we are able to split successfully this water into hydrogen and oxygen, we can use oxygen for different purposes. Like there are many issues like the respiratory issues and all. We usually use this oxygen, right? In the oxygen mask is very important in the hospital, right? So we there is nothing to waste. Like whatever you get from the water, hydrogen and oxygen both are important, and they are very useful. And hydrogen is used as fuels. So in most of the fuel cells, you can see, and nowadays there are hydrogen vehicles also there. You know, the Nitin Gadkari, our transportation minister. So he had he has one vehicle that is powered by hydrogen fuel. So this is not what I mean to say is like this technology is not far. Still, it is in growing stage, but people are using it. So this comes from water energy. That means it's a renewable kind of things. So hydrogen, coming to the hydrogen, we have 3 steps we need, like hydrogen generation. The first step, we have to generate hydrogen from water. That means we should split water successfully from hydrogen and oxygen from water. And then another important and a task is storage. You know, hydrogen, it's a light element gas, right? So we need a big container, big space to store it. So it is not practical storing assets. So what we have to do is we have to compress, or we have to liquefy it by compressing. And hydrogen, it is is very explosive, and it's not feasible to use in normal atmosphere. So we should be very careful using this hydrogen. It's explosive than many times than the petroleum products and all. So we need more technologies for its nice handling and all. So storage is again another issue for the we are overcoming that issue. Different research people, and again the utilization also, as it is a explosive gas, we should be very careful while utilizing it. So the supply part also should be we have to invest a lot of. So the existence of this in nature is we have, coming to the gas, we do not have hydrogen. We cannot use the natural hydrogen because natural hydrogen is very less. It's less than 0.00005%. So the most of the majority is nitrogen and then oxygen and argon, this kind of things, right? So hydrogen as free gas we do not have in our atmosphere. So what we have to do is we have to get it from the water. So that's why the catalysis become important, because the people, the thermodynamic potential for water splitting is around 1.23 volts. So we have to give this voltage, and you have to separate hydrogen and oxygen. So that means it is a kind of instead of making a glass of tea, you are spending a bucket of tea. It's kind of thing. You are using a lot of fuels and you are getting small amount. That is the issue why using the conventional method. So that is why people, they try to reduce this overpotential 1.23 volt to below 1 volt. Then only it is economic. You have to give a small potential to divide out to split the water, then only it is useful. If you are giving much energy to split, that means it is not convenient, right? So this is why the people are working on catalysis part. Like many materials, they are very good catalysts. They can reduce this potential and they can enhance the production. So this is for the catalyst. And there are photoelectrochemical catalysis also. That means instead of giving the electrical energy or electricity directly, it can use the solar energy, and it can use that energy to convert. So now this is the green hydrogen. There are hydrogen technology, and green hydrogen mission also is there for the government. So what is green hydrogen means? You have to use the energy that's from renewable energy, not from the coal. Suppose if you are using our electricity, whatever we are getting, because we are getting majority part. We already saw some slides like its majority comes from the coal. So that is not good. Using the electricity from coal to divide this water, that means it's not completely green. So we have to use the renewable energy to split the water. Then only we can say the technology is green. Okay. So PEC is a green hydrogen technology, photoelectrochemical cell. So Jules Verne, you may know the scientist. So long back he commented that I believe that water will become one day as a fuel. So that's what happened now, because the hydrogen is producing from the water and we are using it as a fuel. And this all the energy economy. Maybe I will skip this slide. And energy generation storage. Yeah, here again hydrogen. Need for energy storage, like we need a storage is an intermediate steps. That means in between generation and supply. So hydrogen production, there are different methods, like the green production, green hydrogen production. We use the renewable energy, that energy from maybe from biomass, wind energy, solar energy, natural gas. That means it is not green, but still there are people, still there are hydrogen plants. They use the natural gas and coal, and sometimes nuclear fuels also used to split the water. So coming to the statistics, now the hydrogen production, 48% is from natural gas, and then 4% from the electrolysis, and coal 18%, oil 30%. So renewable energy conversion, these are the technology we use. We use the heat as thermolysis, and mechanical energy we use as electricity or electrolysis, and then biomass we use to convert the water into hydrogen, and photolysis also is there using the sunlight. And this is a structure of a electrolyzer, water splitting electrolyzer. You can see there is this, it's a cathode and anode. In cathode, the reaction is like hydrogen production. That means you can get hydrogen at the cathode and you can get oxygen at the anode. The anode, it is oxygen evolution reaction. Cathode, it is hydrogen evolution reaction. So the potential for the hydrogen evolution reaction, it's usually 0 volt, but it's practically it's not. It exceeds the 0 volt. But for oxygen evolution reaction, it is 1.23 volt, the theoretical value. So total water splitting, it's become 0 plus 1.23, so it is 1.23 volt. But it is not, it is the theoretical value. So usually we need more than 1.5 volt. That's why I already said like it is not feasible using 1.5 volt to split the water molecules. So that's why catalysis become very important in this sector, because in order to reduce this sour potential and to enhance the production. Now coming to the hydrogen engine, it's kind of fuel cells, like it's used hydrogen for the internal combustion instead of the natural gas of coals, and it uses it's used for for the driving force. And this is the structure of a fuel cell. You can see this is solid oxide fuel cells. So you can see the structure. It is porous anode is there and porous cathode is there, and in between the electrolyte means it is a ionic conductor. So ionic conductor means it can conduct the oxygen ions. So the reaction is like at the cathode you will have the oxygen plus 2 electron or 2 minus. That means air oxidation. And then at the porous anode, this oxygen it has to conduct through this electrolyte and it should reach at the anode. In anode, there will be a reaction like H2 plus SO2 gives H2. That means the byproduct is water. That because so you can see that there is no emission of any toxic gases and all. So that is why this hydrogen, we call it is a green fuel. So if you use hydrogen, the byproduct is water only. So it may not harm the environment. It will not harm the environment. That's why it is green. Now working principle on maybe I can skip this. Maybe difficult to all to understand. And there is another technologies. So of course, whatever technology I show here is like what I am working on the field. There are many other technologies also. So this is 10 is nothing but it is triboelectric nanogenerator. You may hear the piezoelectric, right? The same way triboelectric is like is using the static energy. We know that we studied in our intermediate, like when we use the comb in the air, hair. So the charging we can observe, right? So you can, if you keep a piece of paper, it can attract a ripple. So that means there is a static energy generation. So it's same concept only. Triboelectric means it can have different types of operations. So in these operations can have generation of static energy. So this static energy can be converted into electricity. So this is actually, it's a very, very small scale industry tank. That means it is using only the wasted mechanical energy. It's not like it's not a large scale production. It's a very small scale production only, in order to use like the street light, in order to power the street light, or maybe for the sensors and all. So it is very small scale industry. So what it do is, it's available energy. It can, like the wasted mechanical energy, the human motions, we are wasting a lot of energy while we are walking or running, right? And the wind energy, or maybe water waves, sound, and magnetically induced motions. So these all types of mechanical energy we can convert into useful energy using triboelectric nanogenerators. So triboelectric generators, the structure is like, it will be two layer, like one positive layer will be there and one negative layer. So whenever it comes to contact, this positive layer and negative layer comes to contact, it can generate the static charges, like positive charges in one electrode and negative charges in one electrode while you separate it. So again, if you make it contact, it conducts. So this is the technology actually. This is the theory behind it, and we can utilize this energy, the wasted mechanical energy, using this triboelectric nanogenerators. And there are many. This is the working mechanism for the triboelectric nanogenerators. So you can see here. This is one is positive layer and another one is negative layer. So the opposite charge will be stored there. It's similar to the dielectric capacitor. The main drawback is like it is a small scale production only. Like you can like in in volt, in kilovolt you can get, but the current is in milliamps. But still, if you can increase the area of this type of material, you can generate a good enough volt. That means energy. So you can see there are many ground indoor stadiums. They use this triboelectric generated energy to lighten their ground. And many kids park also. It's already there in Europe. In Europe, they are leading in this research area, and they already implemented in many kids park and all. So whenever the movement is there, it can generate the triboelectricity and they store it, and they can that energy is used for the street light and the light inside the indoor stadiums and all. It is not like it's a you cannot completely run the ground and other industries and all, but you can use the small scale way you can store and you can utilize it. So this is what we generated, we like developed in our lab, 2 layers, and we got like this comes the research what we do, and we could develop in milliamps some current and in some voltage. So here you can see this is this. Maybe the value is around 1 volt, and the current we measured, maybe coming slide I will show. So this is actually the structure of the triboelectric generator. Yeah, so you can see the open circuit potential and the short circuit current. So this almost 4.9 volt we generated, and then 1.6 microamps, not in milliamps, microamps. We have to improve a lot. Like we have to increase the size, and then you can like get up to maybe milliamps and all. Yeah. Now these all are the energy conversions. Now coming to the storage. So coming to the energy storage unit also very important, right? Why? Because coming to the renewable energy source, renewable energy, there is the major drawback of the renewable energy. We know it is seasonal, right? Suppose the hydropower, when we can use only in rainy season in Kerala, especially in Kerala, right? Only in rainy season only we can use the hydropower. In summer we have the shortage, scarcity of water, so we cannot use. And coming to the solar only daytime we can use, and that too in the summer, right? Not in the rainy season, or if some cloudy atmosphere we cannot use. So wind also. So all these renewable energy sources, they all are seasonal. So we cannot get a continuous supply from that. So this is why the importance of energy storage unit becomes. Because energy storage unit is it's an intermediate unit in between the production and supply. So we have to produce a lot of energy when we have plenty of sources, and we have to store it somewhere, and we have to use it whenever the demands comes, right? So that is why the energy storage technology is also very important nowadays. So energy coming to the energy storage technologies, there are many we know many sources are there like mechanical energy, thermal energy, electrochemical energy, and electromagnetic energy. The same way we store also in same way. Like so that's why there are mechanical energy storage and thermal energy storage, electrochemical energy storage, and electromagnetic energy storage. So what I'm focusing is on electrochemical energy storage in my view. So we have batteries, we are developing batteries, supercapacitors, and fuel cells. Fuel cells already we discussed. So energy storage is the most simplest way we can understand using a Ragone plot. A Ragone plot is nothing but this is specific energy and the plot between specific energy and specific power. So we know that whenever we go to the market and we buy some energy source like some device like batteries and all, what we usually ask shopkeeper, we ask like how long I can use it. That means how much energy is stored, I can store inside, right? That may be our first question. What is the durability of this battery? And the second question is, if it is a rechargeable battery, we ask how fast I can recharge it, especially the electric vehicle nowadays. The advertisement is like you can charge within 1 hour, 2 hours like that, right? And you can use for maybe 300 kilometers, 400 kilometers. That means the question is how long I can use and how fast I can charge. That is the second question, right? So these are the two questions we ask to the shopkeeper or whenever we buy some the products that are related to the energy, right? So this is why we can compare the materials, different devices in energy storage devices, like the ordinary capacitors, the dielectric capacitors, and supercapacitors, batteries, fuel cell. All these four you can compare using a Ragone plot. So how fast means it's a dynamic process, right? So this is like a rate is there, how fast. So it is power, specific power, you can say, in the y-axis. And how long means it depends upon how much energy you have, right? So this is depends on energy, how long. So this is the Ragone plot. It's a comparison between these two questions. That means comparison between specific power and specific energy. So for a device, we need both the question we should be answerable, right? It should be used for fast charging and discharging. It can be used for long duration also. I can use with a single charge. If I can use 500 kilometers, then it's good. If it is only 2 kilometers, people will not buy. So which device is best? That means we should have more specific power and more specific energy. So something that stay here, right? The rightmost corner, some device, that is the answer for these two questions. But unfortunately, all devices, they have some plus and minus. So the capacitor, if you see the dielectric capacitor, it's have very high energy, sorry, high power density, but the energy density is very less. That is why the capacitor, you know, in our ceiling fan and all, we use this capacitor. Why we cannot use a battery, 1.5 volt battery instead of capacitor battery for the initial thrust? Because its energy, power is very less for a battery. Capacitor has very high power. For the initial triggering, we need high power. That is why it is used capacitor. And if you use a torch light, we do not use capacitor for torch light, right? We use the batteries only because that means it's a constant supply of energy for a long duration. That is why batteries comes in high energy density, not in power density. Fuel cells also, like as much fuels I have, I can use. If you have a very good, very big fuel tank, you can use for a long time. But fuel also, it has to combust and it has to produce electricity. That means it's a slow process. So that is why supercapacitors came in today. Like it have both the advantage of specific energy and specific power. So depending upon the materials used in the electrode of supercapacitor, you can replace both batteries and capacitors. So this is it's a bridge between capacitor and batteries. So more simple way you can understand this, like it's a battery is like a marathon. That means you need a constant energy for a long duration. And a capacitor, dielectric capacitor is like a high jump. You do not have the energy for a long duration, but the moment the demand comes, you have to give the entire energy within a moment of time. It's like a high jump, right? When you jump, you have to put all your energy, right? And fuel cells, like it says scuba diving, how long, how much oxygen you have in your tank, you can stay under the water, right? But a supercapacitor, it's like a 400-meter race. That means you have to finish 400-meter, and also you have to be the first. That means you have to run fast. So you have to complete also, you have to run fast also. So supercapacitor is more or less similar to this a 400-meter race. So these all are the images of supercapacitor that you can see in the market. So why the name supercapacitor? So before going to the supercapacitor, we should know what is a capacitor. Capacitor, you may already know, a dielectric capacitor is nothing like a parallel plate capacitor. For the simple understanding, we can take an example, parallel plate capacitor. There are two metal plates, right? And in between, there will be a dielectric medium. So this is like when you apply some potential across these two plates, the dielectric medium, what it can like polarize the material, right? So the positive charges and negative charges will be stored in the opposite polarity. So this is what happens in a dielectric capacitor. And we know that the capacitance equation for a dielectric capacitor, it is epsilon into A by D, right? Epsilon is the dielectric constant, A is the area of any plate, conducting plate, and D is the space between, or distance between these two plates, right? Now coming to the word supercapacitor, something super we call, when we call super, we know the superconductor. When we call it is superconductor, because conductivity is very high that we get in ordinary metals, right? So this is why we call superconductor. Same way supercapacitor also, the capacitance is very high compared to the ordinary capacitor. So how we can get that capacitance? The only way is you cannot increase this value, because this is constant for any material, right? Epsilon is constant, and you cannot you can only do in two ways. One is you can increase the area, and another one is you can decrease the distance between plates. This is the only two ways to increase the capacitance of your capacitor. But we know the limitation, because how large we can make a capacitor. There are many limitations, right? And how much smaller you can make the distance between. So these two are limited, right? So now the supercapacitor is because what they did is like they just replaced the dielectric medium with an electrolyte, and electrode, instead of metal plates, they used the porous materials, say porous carbon. So we know that porous carbon, the surface area is very high, around 2,500 meters square per gram. And if you use electrolyte instead of the dielectric medium, you can store these electrolyte ions in the pores of these electrodes. And also, whenever you have this electrolyte interaction with the electrodes, porous electrodes, you may have, and if you apply the potential, you can have, you apply the potential, you can have the storage of this, like the static charges or the electrolyte ions inside these pores, and there will be layers, like first layer, maybe if your electrode is negatively charged, then there will be a positively charged ions adsorb the surface, and again after that there will be a negatively charged layers. So similar kind of many layers will be there. So, and the size of these layers, maybe it's like ions, right? So size of ions, it is in Armstrong. So that is why the d spacing you can reduce up to the Armstrong unit. And the area is like it is porous carbon, you can around thousands of meters per gram you are getting. So this is how a supercapacitor is getting very high capacity. Hope you understood that one. And that is the principles. Now coming to the supercapacitor, there are many different types of supercapacitors are there, depending upon the materials we used. Like the most common one is like double layer capacitor, EDLC, electric double layer capacitor. EDLC is made up of carbonaceous material. That means you cannot give any redox reactions like batteries. But pseudo capacitor means it's more similar to electric double layer, but there will be a surface redox reactions. Like it's not like batteries, but compared to EDLC, it's have a small redox reactions also. It's a combination of both. And hybrid capacitor means you can have one electrode from EDLC behavior, another one pseudo capacitor. So if you use combination of these two, then you will get hybrid capacitor. So what is the peculiarities or what is the specialities of these three classes that we can understand maybe mostly in this slide. So if you are having EDLC, EDLC is like electric double layer capacitor. That means it is more or similar like our dielectric capacitor. It's just a polarization and absorption of ions on the surface. It do not have any bulk property. But pseudo means it has some bulk property. It can penetrate into the electrode materials. And you can have redox reactions like batteries. And hybrid means you will have combination of both this EDLC mechanism and pseudo mechanism. That means combination of it is like in between batteries and capacitor, right? So now you can understand what is the use of this. If you have an EDLC, that means EDLC means only absorption and desorption. That means it is a very fast reaction. You can easily charge and you can easily discharge. It's like a drinking water in a glass. Like you can refill very fast and you can consume also very fast. But if you take a battery, then it is like a water can with a small opening. That means filling and taking is very difficult. It's a slow process. But if you use hybrid or pseudo, then that means only surface you will have this kind of reaction, but in bulk you do not have. So this is more or similar to EDLC plus surface redox reaction. So it is faster compared to battery, but slower compared to EDLC. So these all are the characterizations. Maybe it's not be familiar to you. This is we call cyclic voltammogram, and this is charge discharge cycle. That means potential versus time. And these are the factors we use to validate the performance of a supercapacitor. Energy we calculate, power we calculate, and capacitance and specific capacity. Okay, and applications we know smartphone it is not implemented still, but there are applications in UPS, crane, and emergency windows and all. Supercapacitors are used. And you know there are buses, electric buses and train. They use supercapacitors. So the limitation of supercapacitor we know compared to battery, we cannot store much energy because it's only surface is used. So, but we can fastly charge. Like the fast charging is possible with supercapacitor. So what they do is like every stop the bus or train has to charge, and the charge will be last up to the next stop only. It cannot run all the area. But the time for like passengers getting down and getting on, that time is enough. 1 minute or 2 minutes is enough to charge the supercapacitor. That's why it is possible. Now the electrode materials, I will skip this part. These are the materials used. And coming to the energy grid applications, now we know supercapacitor, we cannot replace the batteries or we cannot use in the grid application because energy grid we need like bulk storage. We need to store a lot of energy. That's why we are not using this for the energy grid application, but for maybe electric vehicle or maybe portable electronics and all, it may be used. And it is used, not maybe, it is used. Now coming to the grid applications, then we have to move to the batteries, right? Batteries having bulk energy storage property. Okay, now coming to the battery, we know the master of battery is lithium-ion battery. Everywhere you see your mobile phone, your laptop, your electric vehicles, everywhere you can see lithium-ion battery, right? But the problem with lithium-ion battery, we know that the positive things we know, it is very light. That's why it is very popular. It's lightweight. Lithium is after hydrogen. Lithium, you know, the lightest element in the periodic table, and it is very very easy to charge and discharge. The process is the chemistry, battery chemistry is very. But the problem is like there are many issues using the lithium-ion battery. You may hear that you may see in newspaper many electric vehicles, they catch fire, right? And there are issues like the 2 years back in South Korea, one battery one battery factory, it's got fire and around 20 engineers were dead, killed, right? So this kind of issues are there. It's like a nuclear reaction. Like if battery means it's a combination of cells, right? There are many cells in parallel and series way connected. So if one cell get fire, it spread into the next one. Again, it spread to the next one. So it's like a chain reaction. And because of the lithium battery is highly flammable because of the electrolyte, organic electrolyte used inside, and the short contact happens in the lithium battery. So these issues are there. Another issue is lithium is very expensive. It is not distributed uniformly in the globe. So it's not plenty. It's not like it is not abundant in the nature. So it is very expensive. So these two are the major drawbacks of lithium battery. That's why people are thinking the alternative source or alternative material for batteries. So again, coming to the lithium battery, it's not only lithium that decide your um, property. There are many other things like what the electrode material is made up of. So there are many class of lithium and battery, especially used in the electric vehicle. LFP. LFP means lithium iron phosphate. And there are NMC, that is nickel, manganese, cobalt. And there is NCA, nickel, cobalt, aluminum, and lithium titanate, LTO. And there are solid state. This is the future technology. Now research is going on solid state battery. So compared to this LFP, lithium iron phosphate is highly thermal stability is there, long cycle life is there, and the cost wise also it's good. And NMC, it's a high energy density, better driving range, and that means you can have long use and balanced performance. And coming to nickel, cobalt, aluminum, this very high energy density is there and used in EVs. It is mostly used and requires strong thermal management. And then lithium titanate is ultra fast charging is possible, but coming to the durability, the energy you cannot use for the long time. It's very low energy density. Okay. And coming to the new technology, that is solid state batteries. Solid state battery, why it is very important is there are two things. We know there is a dendrite issues, like why these batteries get fire, because every time suppose you take the lithium battery, in the anode you have lithium metals, and in cathode you have a metal oxide. Suppose it is a manganese oxide, right? So what happens while you charge? So lithium already intercalated, cathode material with the LiMNO2. Okay. So when you charge, what happens? This lithium comes from the lithium metal and it's go to the cathode material and it's intercalated there. So it's a mostly layered structure, right? And coming to back also, while you discharge, what happens with this lithium from the manganese oxides come back to the electrolyte and to the lithium metal. So every charging cycles, what happens? The 100% lithium will not come back. There will be less than 1% stick over there. So every time this lithium will stick over there and it becomes like it's like a road, it will grow. So that is called dendrite. This dendrite, what happens? It's after certain cycles, 100 or 200 cycles, this become very big and it contact your cathode material. So anode, cathode contact, a short circuit will be there. So this short circuit creates spark, and because of this electrolyte inside the organic electrolyte, it's get expired, right? So that is the issue we face. So in order to overcome this issue, solid state batteries are very important. So solid state battery, what they use the electrolyte also solid state electrode. So it can reduce, it can suppress the dendrite formation, and also the catching fire issue also it can manage up. And the problem we face is the conductivity of the electrolyte. Any conductivity is less in solid state than the liquid state. That is the only issue. But there are many ionic conductors in solid form. So people are doing research on this area, and maybe, hopefully, maybe within a few years, we will get solid state battery in everywhere. Okay. Now coming to another technology, that is zinc ion battery. So we are working on zinc ion battery in our lab. So Shajil sir, how much time left for me? Hello? Hello, am I audible?
Yes, sir.
Yes, you are. Yes, you are.
Okay, okay. So can I take 5 minutes more? It's almost
Oh,
1 hour.
sure.
Okay, thank you.
As long as you need, to finish
Okay,
the
okay.
talk.
Thank you. Yeah. So because of this issue we face in lithium and battery, there are other batteries, sodium ion batteries, zinc ion batteries, aluminum batteries. So why it is important is the first thing is the availability of lithium. Lithium, we know it is very, like it is not distributed uniformly and it's very expensive. And second problem is the explosion, like the catching fire issues. So in order to overcome this, the first issue is like the availability. That may be, we can use the naturally abundant materials like zinc and sodium. These all are like abundant compared to lithium. It's more than 10 times it is abundant. And aluminum also. But still, if you use the organic electrolyte, we have issues of catching fire. So in that aspect, what we have to do, we have to replace this organic electrolyte with something is not non-flammable electrolytes. So we are focusing on aqueous zinc and batteries. So aqueous zinc and battery is the electrolyte is a aqueous solution.
So
that means yes.
the slide is invisible. The slide is invisible. It's not visible.
Slide is not visible. Okay.
Yeah.
Yeah, it's fine, I think.
Now it's fine, sir.
Now it's
Okay, thank you. Yeah. So why aqueous zinc ion battery is because first one is the electrolyte is aqueous solution. That means if you have some short circuit, it can suppress the firing issues. It can reduce it can cancel the fire. Another thing is zinc is abundant, and again zinc is 2+, lithium is 1+. That means one lithium can give 1 electron, zinc can give 2 electrons. That means the energy density is double. But coming to the weight is compared to lithium, okay, it is heaviest, but still it gives very good energy. That's why it is not used in portable electronics. But yes,
it appeared once and disappeared again.
Again.
Yes, sir, it's visible.
Oh, again.
Again gone?
Yeah.
Yeah, I think when I maximize it in presentation mode, it is happening. Maybe I will share a entire screen. Now it's fine, right?
So screen now, yeah. It's fine. Now it's good.
Okay, thank you. Yeah. So that is the reason we use the aqueous zinc ion battery, and you can see the gravimetric energy and gravimetric power, like the Ragone plot. Also, it's the position is good compared to other energy storage devices. Like we have high power and high energy here compared to all these, right? So this is the leading one. Of course, sodium ion also is there. It's also have potential applications, but the problem, there are some dissolution issues are there. But we know that zinc ion battery is not new. It's a long back it is started, but the rechargeable zinc ion battery, the research is going recent years. Know the histories and all, okay. So the main advantage is the multi-electron transfer as it is Zn2+. Yes. But still there are problems we are facing, the dissolution, sluggish diffusion and dendrite issues. And also what we are doing is we are working on electrode materials, and we are trying to suppress the dendrite issues and other drawbacks. Low ionic conductivity and all. Low ionic conductivity, we are using the materials like perovskite oxide materials Perovskite oxide materials have the inherent properties of it can have both ionic and electronic conductivity. There are multiple cationic sites and oxygen vacancy also used for this ionic conductivities. And so these are all some examples we did in our lab, zinc and batteries studies. So perovskite oxide materials usually we use for these applications. Perovskite oxide is nothing but the name AbO3 structure. There will be A cation, B cation, and 3 oxygens, AbO3. So what we can do is in order to get electrical conductivity, you can substitute this material with a lower valency. Right? Suppose it is A3 plus, B3 plus, and O3 6 minus, right? Then if I use instead of A3 plus, I use F2 plus, then there will be a charge imbalance. That means you can have a hole conduction here or electron conduction, right? Same way, if you create a oxygen vacancy here, you can have the ionic conductivity. That means oxygen ion movement. So this is how we are improving our ionic conductivity and performance of the lithium-ion battery. So we'll not discuss all these things. So applications again, we are used this zinc ion battery mostly used in grid applications because it is heavy compared to lithium ion battery, but still the energy density is very high. So for a static energy storage device, we are not aware of the weight, right? So that is why we can use this for the static applications, like for the energy grid applications, power grid applications. Now these are all the works we did. Yeah. So this is my lab, lab members. Usually whatever results we showed, they also contributed. Their contribution is also, it's very important. And we are thankful to my lab members, and I am also thankful to the government organizations like Department of Science and Technology for the Inspire Faculty Fellowship and give around 35 lakh research grant I got from DST, and then ANR of Anusandhan National Research Foundation. We have one project that is in triboelectric nanogenerator, and then ANERT is the Agency for New and Renewable Energy Technology, Government of Kerala. Of course, National Institute of Technology, Calicut, and then GC Carbon. It's one private company. They also support us. Okay, thank you. Hope it's done well. If you have any doubt or clarification, we are happy to discuss. Yeah.
Hello. Am I to say something? Comment. We are. In fact, I was listening it attentively, not include in most of the webinar. It's a very, 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 what do you call, not only educative, it's informative as well. And more. In addition to that, I find the way the whole thing is articulated and presented, it has a great deal to do with the subject, more than the subject also. A lot of things students have learned from there. See, the way Dr. Muhammad Shafi acknowledged gratefulness to organizations which he benefited in his profession and education and all that. and various attributes which we should cultivate in ourselves and also articulate when we get occasions to do it. So that way, there has been a very nice topic. Now, I would like to say something more, but I know that students are anxiously awaiting. It has been a highly educative, informative, and a wonderful talk. In fact, I recall this is something like an elaborative article I have read in this more than, and it is an hour plus 1 you are taken, more than 1 hour you are taken for it. I think it is a very, very good session, and I am very, very thankful for accepting our invitation here and giving us such a wonderful talk. And this is a topic which is a rare one. This is an issue which is larger issue for the world at large, and technology which has to help the world to overcome the energy crisis. So it's very nice. It's an excellent occasion that we are having this webinar now. Thank you very much. Thank you very much. You are very kind. And thank you, Dr. Shahid and Dr. Shahi. And us. Good base in IT. Thank you very much.
Thank you, sir. Yes.
Yes, sir, I'm there. So thank you so much, sir, for such a deeply insightful and intellectually engaging session. As you were speaking, it reminded me of a key idea often emphasized in modern research, particularly in interdisciplinary science, that the real challenge today is not the lack of data, but the ability to extract meaningful, reliable, and scalable insights from increasingly complex systems. This has been a recurring theme across recent research papers and global scientific discussions. Your session reflected exactly this shift, moving beyond just understanding concepts toward interpreting, applying, and translating them into impactful outcomes. Now, we have received a number of thoughtful and well-articulated questions from our participants, which clearly reflects their curiosity and engagement with the topic. So now, let us move into the Q&A session and explore some of the questions. Shall I, sir?
Sure.
So the very first question we are having it from Adil Prajesh. He's asking that, can using specific colored lights can make the energy sustainable, not like changing the white light into blue, but maybe in some labs or parties or such places where white light is not so important?
So the question is like, can we use the multiple color? I didn't get the question.
Sir, can you please say?
Sir, I am Adil Prajesh. So my question is like, in places like street and such places needs white light so important. Changing it to red or blue makes it impossible to navigate. But some places like maybe parties or such labs where white light is sometimes not so important. So making it to any colors like red, green or blue, yellow can make the energy so sustainable.
Oh, okay. Yeah. Very good question. You are asking like the frequency and of the the energy. So usually the LED what we use, it's like mostly give white light, right? Why it is? Because in white light only, that means then only you will get the original picture, right? Original view of the object. That's why we are using that one. But in order to reduce the energy consumption, you're asking like whether we can use a particular wavelength, right? So that may be possible, but the thing is like we cannot replace white light with colored light, right? So that may not be possible, but I don't know, is there any optical applications in optical way? I'm not an optical physicist. I'm from material science. So in that way, I don't know how to answer your question, but why we are using white light is because for the object recognition, we need a white light. We cannot use other lights, right?
Thank you, sir.
Thank you, sir. That gives us a clearer understanding of transition from theory to implementation. So, can we move on to the next question?
Yes, please.
It is from Shankar, who is studying in class 10 at Devagiri CMI Public School. So, he's asking that I have a question about TNGs and how can triboelectric nanogenerators generate energy constantly for functions like lighting a basketball court?
Yeah. Very good question. Yeah. So triboelectric, we already discussed, like it's like more or similar to the piezoelectric or static energy, right? So in a ground, like suppose it is a kids playground, right? So kids playground, the kids always they jump and run, right? So every time they hit the ground and release, hit and release, right? So if we use tribo positive and negative layer, like with a small distance, right, like this. If some object is coming to hit here and it will become contact. Once it release the foot, it become non-contact, right? So every time it generate energy. So an alternative like AC current it can generate. Okay. So if you can separate this energy every time to a module, then we can use this as a electricity, right? So an alternative current waves or voltage waves we can generate. So this is how we are generating that energy. But the problem is this is like it's very, very low energy. It's not much energy. That's why the entire area if we use, because the material we use for the triboelectric nanogenerator, they are polymers. They are not much expensive. The natural polymer also you can use. You can use the cellulose, or you can use the PVDF, or you can use PVC, these kind of things. It's not much PVC, it's not expensive. So this kind of material can be used for the flooring of the kids playground or the sports ground. So with the good management, we can generate this energy for only to lighten the ground, not to use the entire energy, but we can support maybe some percentage using from this triboelectric generator. So triboelectric, and there are piezoelectric also, but piezo, the issue is not, the efficiency is less compared to triboelectric. Piezo also used. Yeah, and there is also thermoelectric generators. Whenever we have some like change in temperature within the material, then we can use the thermocouple and we can use the Seebeck effect and all, you may know, right? So there are these three are very common, but triboelectric compared to others, that efficiency is high. That's why it is already implemented in many European countries.
Hello, sir.
Yes, please.
I actually use the triboelectric nanogenerator for my school science fair. And one of the problems that I faced was that I could not light up a battery properly because of the low amperes. Light up a battery. So I had to connect it to a voltmeter so that it can show some readings.
Yes. It's happened. What was the size of that?
No, it was like using paper, aluminum tape, and polyamide tape.
Did you use any capacitor in between, like any power circuit?
No, we actually planned to use a capacitor, but then by that time it was almost the deadline.
That's why you couldn't power the LED and all. You can at least show the LED instead of voltmeter.
We can see the readings, and that was enough.
So there is another step. The second step is like the power optimization. So you have to use different resistors, and you should find at what resistor it gives maximum power. Okay. Then you have to fix it, and then you have to use a capacitor, an intermediate, and then you have to convert this like a continuous, into a constant potential, and then you can store into a battery. Then from battery only you can use. Yeah.
We cannot use like a voltage amplifier to increase the voltage. No, to increase like the amperes.
No. First thing is you are getting this an alternative source, right? Every time the polarity changes, right?
Yeah, we have to change it into DC current.
And also every time you are not getting same signal, the amplitude will be different. So you will get a non-uniform signal. So first you have to make it to a static or a stable current, right? So for that, you have to optimize the power delivery by using different resistors and all. And then after that, you have to store it in a capacitor, okay, in order to make a constant potential. Then you have to store into a battery.
Yes,
So there
sir.
are, power circuits.
But there are still like a lot of problems. Like we have to rub it a lot so that we can get a small amount of power.
Yeah,
and
rubbing,
so practically
that means it is maybe static energy. So you are welcome to our lab. You can. I showed already some devices, right? What we prepared in our lab.
Yeah.
So you can, if you are interested, you can come and see.
Okay, sir. Thank you, sir.
We usually conduct some outreach activities, like Sajil sir already said, right? Sujit sir from NIT Calicut. He always conduct every month, at least he make some school visit. So every school visit, Sujit sir ask our lab also to show something. So we are showing these kind of things to the school students also. So if you are interested, you can come and visit our lab.
Yes, sir. But practically, how is it used? Like, how can we practically use it? We have to like apply.
Yeah, I showed, right, some slides I showed, right. There are it's already implemented in some places in European countries like Ireland and all.
Yes, sir. But
you know, yeah, another example I will say. So there is one professor from IIT Indore. His name is Palanisammy, Professor Palanisammy. He's from Tamil Nadu. He's working on IIT Indore. He has a project from DRDO, the Defense Ministry. So what is the project is like, he made this triboelectric nano generator and integrated in the boot of soldiers. Okay. So because some soldiers has to move in different locations, right? So the GPS may not be available everywhere. So the triboelectric generator is used to generate the electricity, and that is used to power the GPS and to locate for the sensor also, and to power the sensor and to locate the GPS. So already he sold around 100 shoes to the defense. So it is practical. That's why they bought it, right? Otherwise, the soldiers, they won't buy it, right? DRDO won't buy it. They bought it. It is practical. Yeah, it is.
Excuse me. Yeah, I have seen another use. Like I have read about it. It's like using in the flywheels of a spacecraft.
Yeah. Everywhere, wherever we have some mechanical energy loss, we can use. Some friction
but the power can be only used to like power small IoT network. Like
yes. But still, if you increase the area, you can support, right? You cannot get the whole power from this, but you can support. You can reduce using other depending other sources.
But increasing the area of like a lot of solar panels, that is more efficient.
Not solar. It is not solar. It is
no, but that produces more energy, right?
Yeah, it is cheapest. The materials are cheap. I told you, right? PVC is one best example. Yeah. So anyway, you have to make with some material, right? So that material may be tribo material.
There is another tribo material, right? Using like coffee beans.
That is from the biomass derived materials. Yeah. That also, the research is going on.
Okay, sir. Thank you, sir.
Nice question. Thank you.
I hope that cleared your doubt. So that was very insightful. Thank you for clarifying that so clearly, sir. So moving on to the next question. This is by Adil Prajesh. Which is the most disappearing, rapidly decreasing in a short energy source in the whole world, and which is the most likely getting birth, rapidly increasing in a short time?
Can you repeat it? Sorry, pardon me.
Sure, sir. Which is the most disappearing, rapidly decreasing in a short energy source in the whole world, and which is the most likely getting birth, in the sense rapidly increasing in a short time?
Yeah, very good question. The answer is fossil fuels, right? Fossil fuels, I already said. This is like, it will disappear within 100 years. We will not have. The world is currently, we have the stock maybe up to 80 years or 90 years. So it will disappear once. If we are like 100%, we are depending on the fossil fuels, then it will disappear very fast. And the upcoming one is the nuclear one, of course. Nuclear now, in my slide, it showed in 2016, we were using 5%. But now if you take the statistics, almost 20% total energy we are getting from the nuclear. So nuclear energy nowadays it's become more safer and more safer. You may wonder like how it is safer. So if you have the initial investment like the lead block and all, if you use, you can have very good efficiency from the nuclear plant. So nuclear plant may be the fastest growing, and the disappearing one may be fossil fuels.
Thank you, sir.
Yeah.
So the next question is from Abhinav, who is studying BSc Physics. He's asking that how close are we to achieving commercially viable solid-state batteries?
Yeah, very good question. Solid-state battery nowadays, the research is like, in Kerala there is ISET Trivandrum, Shaijuman, Professor Shaijuman. He's actively working on solid-state battery, and there are many across the globe also. So now I think within few years, maybe 5 years, we can have the solid-state batteries. Solid-state battery, the main issue I already told, the problem is with the anti-conductivity of the solid electrolytes. So now there are many redox additives and all, and there are many researches going on this topic. And solid-state batteries are like, it's already there. Some companies, they started also developing. But still, my slide, it was showing like nothing is complete. Everything has their own pros and cons. In lithium battery, especially in that slide I showed, LMC, lithium manganese oxide, and nickel manganese aluminum, LTO, LFP, this kind of things. Right? Everything has their own pros and their own cons. So solid-state batteries is, of course, it is the future battery, but still there are many issues that's to be overcome. Maybe within few years, I think before 5 years we'll maybe all the portable electronics may be replaced with the solid-state batteries.
That was a very precise explanation on ensuring robustness in a practical scenario, sir. Thank you. So the next question is from Archit Iyer. He's asking that what energy source could realistically power spacecraft on ultra-long duration machines beyond the Oort cloud and into interstellar space, given the limitations of solar power and the finite lifespan of nuclear sources like those used on Voyager 1 and 2?
In space applications, I have some limitations, but still I read some articles like the nuclear batteries. There are new types of batteries out there, nuclear battery. You might have heard. It is not like generating from the nuclear fission or fusion. It is like breeder reactor, you may have heard, right? Breeder reactor. So it's a kind of making fuels and energy simultaneously. So there are nuclear batteries. So that nuclear batteries are used to power some sensors and all in spacecraft. I read, I don't have much expertise in that field, but I read some articles, that one. And also, 2 days back, that breeder reactor was inaugurated, right? I forgot that place. It is like the polonium, from uranium to polonium conversion. Yeah. So maybe nuclear battery, maybe in the future, it may be used for the spacecraft. But I don't know, you can use for all the applications in spacecraft, but at least for the sensors and all, it is used. Yeah.
That was a very balanced explanation, sir. Thank you. So the next question we are having it from Adidev. He's asking that recently in Germany, many nuclear power plants were shut down. Do you think this is a step backwards? Also, is there any other way to better harness nuclear energy other than generating steam to power a turbine?
Nuclear, as we already discussed, the issue is like we need a large investment at the initial investment, not the maintenance may not be, but initial investment. Like we have to ensure the safety issues and all, like the lead block, the large lead block and all. But I think if you have this initial investment, then I don't know why it is shut down in Germany. I didn't hear that news. So, but still, I hope the only nuclear renewable energy also we have a lot of limitations we discussed, right? It can support, but we cannot completely rely on renewable energy. So I think the only hope in the future is to today's knowledge, it is nuclear only. Nuclear. We have to move forward with the nuclear plant.
Thank you, sir, for the explanation. As you have mentioned that breeder technology, I guess if I'm not wrong, it was in Kalpakam in Chennai.
Yeah. Kudankulam, yeah, Kalpakam, yes.
Okay. And Adil Prajesh is asking, can he ask one more question?
Yes, sure.
Adil, you may ask.
Sir, I am Adil Prajesh.
Yeah.
Before we discover electricity, our main energy source were heat, maybe in the ancient times. We used fire to cook and such things to light, etc. After we discover electricity, our primary energy source is now electricity to light bulb or fan, etc. So is there any chance that we might find any other energy type than electricity, and we kind of remove electricity from our energy sources?
Very good question, and it's a thoughtful question. So electricity, that was the conversion. So electricity is a form of energy that is like we are converting to a useful form. So electricity is like now all the equipments, everything is like it is compatible for electricity, right? So previously it was like it was direct use for cooking, like we use the natural wood and all. So it was like directly heating and using that one. But after the invention of electricity, it's like it's become more convenient. So in future, maybe some other form, maybe it can come, because if it more feasible thing if we find, then of course the world will move towards that. Because electricity, as you said, it's become more convenient, right? So you can store it, you can use whenever it is needed, and you can have a lot of easily you can manage it, right? And you like it's become what do you call it? It's like become in the space issues, like everything, like it's become more compact. Yeah, more compact. Instead of storing, like if you want to store the wood and all, it's long spaces needed, and there are like fumes and other emissions will be there. But if you are converting to electricity, you can reduce all this. So same way, maybe in future, instead of electricity, something like electricity is nothing but it's a flow of electrons, right? Instead of that, if something like neutrinos, if the neutrino can be used as energy source, maybe it may also come. Like that is any other particle, fundamental particle, maybe it may come. But at the present, electricity, people are not even thinking about it, I think. But it's a like output question.
Thank you, sir.
Thank you, sir. So we are having one more question from Adidev. He's asking that, do you think in the far future...
I can add one more thing, like why we are using electricity, because electron is the fundamental particle, right? There are many other fundamental particles. Why we use electron? Electron is lightest and it is a like charged particle, right? But neutrino, photon and all, they are also very fundamental particle, but they are not charged particle. So they cannot make ionization. So in future, instead of ionization, something like you can use neutral particles can use as a fuel or something like instead of electricity, maybe that technology may come in future. Yeah. Okay, so the next question was?
Next question was, do you think in the far future, antimatter annihilation could be a viable way to harness energy, perhaps for deep space travel? CERN already produces a few nanograms of antiprotons every year. Maybe the production could get scaled up in the future.
It's not from my expertise, so I don't want to comment on that question. It may be possible, but I don't know much about that.
Okay, sir. Like he's also having another thing that in the novel project Hail Mary by Andy Weir, a fictional form of life named astrophage is used as a high-density form of energy storage, where photons are used to create neutrinos via pair production to store energy. Though extremely far-fetched, do you think there is any way humans could use similar technology to store energy?
Yes, as I answered for the previous questions, maybe the technology comes to like handle this chargeless or neutral particles, like lightest particle like neutrinos, then maybe technology may comes, maybe in the near future. But at present, I don't know, is it possible or not? It depends on all the, like how the technology change, right? Still, we are facing this neutrino detection and issues because it is everywhere it is there, right? In our universe and our body also is penetrating millions of neutrinos every day, right? But the issues like it's not a ionizing particles. That's why it is not harmful. And also it's not an ionizing particle. That's why it's detecting neutrino is very difficult, right? So if in future it's come a new technology comes to control and detect these neutrinos and all, maybe possible.
Okay, sir. So I basically had a small doubt with respect to that only for the fast breeder reactor which was there. So what are the key technical challenges in maintaining a stable breeding ratio while ensuring reactor safety, sir, there?
Actually, I'm not from the nuclear physics, but still what I read, I can share with you.
Sure, sir.
So yeah. So actually, that is actually, it's like a breeder reactor, it can give energy plus the fuel, right? So it is like a surplus, like it's creating fuel also, and then while the fission process itself, it's liberating a lot of energy. So that neutron, it's emit a lot of neutron. That neutron again, it's hit with the polonium, and it's again gives the energy. So this way it is giving. So that energy. The main issue they are facing is like if I'm correct, uranium, there are two types uranium. In the natural mined uranium, if you take 238 and 239 are there. So I think
is it 235, sir? 235 and 238.
235 and 238 is there. 235 is used, I think, for the breeder reactor, right?
Yeah, one can burn and one cannot.
Yes. So in order to increase that percentage, now research is going on. Now I think at present it is only 0.8%, right? Out of the uranium, only the useful one is only 0.8%. Now the research is going on up to enhancing it up to 3%. So maybe in future it can increase that like the contribution from this useful one, maybe that can give good impact. But the safety concern, as you ask, I don't know much about to answer that questions. Safety concern, of course, it's in a breeder reactor. They are using alpha emitting particles, right? Polonium or plutonium? I don't remember which one.
Plutonium, I guess, sir.
Plutonium, yeah. So plutonium is an alpha emitter, right? So alpha emitter means it's highly ionizing, and then it's it can give a lot of chain reactions, right? Because every alpha again is produce neutron, and it again it can hit another plutonium, and then again it can give. So it should be a controlled process. Making a controlled process may be a difficult task. I read like that, but I don't know much about that.
Okay, sir. Thank you. And once again, thank you for answering all these questions with such clarity, precision, and depth. And I would also like to appreciate all the participants. The quality and the depth of your question today clearly reflected the enthusiasm and scientific curiosity within our community.
Maybe you can have a nuclear physics one lecture maybe in coming webinar.
Sure, sir. We'll take your suggestion. It was truly encouraging to see such meaningful engagement. This session has not only helped us understand the subject better, but has also given us insight into how research, critical thinking, and real-world application are interconnected. On behalf of the entire UL Space Club, we sincerely thank you, sir, for taking the time to interact with us and share your valuable knowledge. It has truly been an honor to host you. With that, we conclude the Q&A session. Thank you.
Okay. Thank you very much. Thank you once again for all your patience and all. And thank you, Shajil sir, for inviting me to this program. I also want to I also want to thank him because and appreciate him because he is taking a lot of effort in his. He is also doing PhD at a time, like he is a teacher also. So he is managing everything and finding time to do all these things. It's a great thing. Yeah. So thank you for inviting me to this.
Sorry to interrupt you, sir, but there is a small question by Adidev that why is plutonium used over other radioactive elements in RTGs in spacecraft?
Yeah, he already told like I'm not a nuclear physicist, so better if I comment, maybe it may be a wrong answer. So better I don't want to comment on this. You can maybe ask a nuclear physicist expert for this question.
Sure, sir. Now I would like to welcome Gautam to say the vote of thanks.
Rishika? Others?
Today topic was renewable energy. We moved to nuclear physics. I understand that many are interested in nuclear physics, so hope you can have a session on nuclear physics. Shajil sir, maybe you can contact Sharif sir from NIT Calicut. Hello.
Hello. Thank you, sir, for the amazing Q&A. I invite Gautam to give the word of thanks.
Others, may I interrupt a minute?
Oh, yeah, sure.
Yeah, fine. So thank you, sir. It was a wonderful session. So I have a quick announcement to make. So as you know, we are in 2026, and every year in the summer vacation, Well Space Club conducts summer space camps for students. And this time, we are actually planning this event to take place in the first week of May. So this is an informal, quick announcement regarding the event. So we are planning the activities, and we have planned a couple of things. So this time, as always, we'll be giving some exclusive entry to almost 50 students who are with us from within the club. So I request you all to be active in all our activities, and further details regarding the camp will be shared through our social media handles. So stay tuned for that. So yeah, that's the thing I had to say. And once again, thank you, sir, for the session.
Yeah, thank you. Thank you all.
Thank you, sir.
Gautam?
Just a minute, sir. There is a vote of thanks.
Oh,
I'm audible, right? Okay, good evening, everyone. On behalf of the UL Space Club, I extend my heartfelt gratitude to each one of you for being a part of our 85th webinar session. It has been a truly engaging session that gave us valuable insights into alternative energy materials and devices, and inspire young minds to think about the future of sustainable energy. So first and foremost, we are truly grateful to our speaker, Dr. P. Mohammed Shafi sir, for this insightful and enriching session. He clearly explained how alternative energy is generated, converted and stored, and introduced us to the modern energy devices such as batteries, superconductors, triboelectric nanogenerators, and etc. Showing us how even small mechanical energies can be converted into usable power. And he also highlighted the crucial role of materials engineering in clean energy technologies, along with real-world applications and emerging science opportunities in energy science. And also, we are deeply grateful to our founder and mentor, Sri Calicut sir, whose vision and passion continue to guide and inspire our space club to reach greater heights. And also, a special thanks to our moderator, Sri Shafi sir, for smoothly coordinating the session and ensuring a seamless flow of ideas and interaction. And of course, a big thanks to all of the participants who joined us today. Your curiosity and active participation are what makes sessions like this truly meaningful. So with that, we are concluding this session. Thank you and have a great evening.
Thank you all.
Thank you, sir.
Thank you.
Thank you. Bye, sir.
Shajil Mash. Shajil Mash. Hello. Hello. Hello.
I think he's
Naveen-
out of. I think he's
Naveen-
out of
Naveen?
station. Yes, sir. Yes, sir.
Navneet.
Yes, sir.
Hello, Navneet.
Sir, can you hear me?
I can. Tell me. Are we going to have any discussion now?
Yes, sir. We have planned a few things. So, like, I had actually mentioned the same to Jairam sir as well, but he said he had other commitments and he was traveling, so he won't be able to attend. So he asked us to proceed with the meet.
Shajil Mash, do we discuss?
So I think
No,
he
no,
is out of
call-
station. Then I'll call him, sir. I'll call him. I'll